Hi everyone! In this video we're going to be talking about measures of center and measures of spread. I want to start off with talking about what the best practices are when you're trying to give some sort of defining features to data sets. We need two pieces of information. The first is to determine a representative data value. That's going to be our measure of center. And our second is to determine a typical distance of the data. The first thing we're going to talk about is measures of center. This is what I said a moment ago was representative data value. There's three typical measures of center. There's the mean, which is the arithmetic average. We typically just say the average. That's when people are saying, oh, what's the average of the data? They usually are implying that they want to know what the mean is. It can be called mu if it's from a population, or it can be called x bar if it's from a sample. I won't be too particular about notation there if you use mu, which is that fancy looking M, or the X with the bar on top. And basically to find the mean, you just add up all the data values and divide by the number of data values, which is what these notations right here that I'm circling mean. That sigma means the sum of all the X data values divided by the total number of data values. Next, we have the median, which is just the middle number in an ordered list. Let's say that list was 4, 1, 3. Well, this isn't an ordered list. We'd have to write 1, 3, 4, find the number in the middle. In this case, it's an actual data value, the number 3. We'll see in an example below that the median isn't always a particular data value. Lastly is the mode, and if we're looking at that same data set from before, 413, it's the number that occurs most often. Well, in this data set, there are no most occurring number. Every data value occurs only once, so there'd be no mode. If there was one more 1, or even one more 3, it would be bimodal, because there's two modes, 1 and 3, or if we didn't have that extra 3, the mode would be 1. Next are measures of spread, and these are what I was calling the typical distance of the data. We have three different measures of spread. The first is standard deviation, and it relies on the mean. Standard deviation is the typical distance of each data value from the mean. There's a very complicated formula going on here. If you're using a population, you're going to call it sigma. But all you do is you take the square root of this calculation, where on the numerators, you're adding up all of the square differences between each data value and the mean, and you divide that sum by the total number of data values. If you're using a sample, it's a very similar calculation, but you do one less than the total number of data values for the denominator of that fraction inside of the square root. I promise this will make a little bit more sense with an example that I have below. Next, we have the mean absolute deviation, which one way you can think about it is it's like standard deviation light. It's a similar calculation where you're adding up all these distances. Remember, absolute value means distance, and where you are looking at each data value. Again, a data value right here, X, that's a data value, just in case we're confused. Subtracting that from the mean, again, mean we can say mu or X bar. Then we take the absolute value of all those distances, because we want them to just be positive, and I'll explain why in an example below, divided by the total number of numbers, which I have written out in words here. It's very similar structure for a calculation, but it's much more straightforward and easier to calculate because there's no square roots going on here in a mean absolute deviation. Lastly, we have the range, which we talked about in a preview in a different video, where you just take the smallest and largest numbers and subtract them. As you can see, the range as a measure of spread just tells you how wide the smallest and largest range distance is. It doesn't incorporate every single value. So let's do an example. What I did is I looked up all the number of minutes in Marvel Cinematic Universe franchise films for each phase. I know this is showing off my interest. That's totally fine. But basically what I did is I looked at how long each video was from the MCU. So I looked at each phase as its own population. You could interpret them as samples, and you have to just do slight modifications to my calculations. But I listed out all the numbers. These are all whole digit numbers based on what I got from the fabulous resource Wikipedia, which for this case is going to be accurate. I would say not to use Wikipedia if you're doing a report or, some harsh data calculations. But for getting numbers like this, it's going to be totally fine. I'm going to go in depth with each way to calculate measures of center and measures of spread using just phase 1. So for phase 1, we want to find the mean. We have all these numbers, 126 through 143. To find the mean, mu, I use mu because, again, this is going to be interpreted as a population, but x bar would have been fine. All you do is add all the numbers, divide by 6, and we end up with 123. What this is saying is that the mean number of minutes for a phase 1 MCU film is 123 minutes. That doesn't tell us much. That just tells us that if you add up all the numbers and divide by the total number of numbers, that's the typical length of a film. It doesn't tell us if there's a film that was only 90 minutes long and there was a film that was 300 minutes long. So we need that measure of spread to really solidify how, or quantify how extreme or regular, if it's not extreme, if it's normal or typical, that 123 minutes is. For median, all I did is I took the numbers, put them in order, found that middle number. In this case, the middle was between 119 and 124, and we got 121.5. What this tells us, since the mean and median are so close, is that this data set is likely pretty normal. I posted some articles onto Beachboard talking about what normal what that definition is for statistics. So take a look at that if that is interesting to you. And again, mode, we had no increasing number of numbers that was shown again and again. So there was no mode for this data set, and that's totally fine. Next is measures of spread. Now for standard deviation, because there's so many parts in this calculation, I like to break it up into looking at all of the data values, then writing down the mean, looking at that subtraction or that difference, then squaring each of those differences. So I just wrote down all the numbers, 126 through 143, wrote on the mean of 123, which we calculated above, subtracted them out. Some of the numbers are positive, some of the numbers are negative. If you notice something, negative 11 and negative 9 cancel with 20. And 3, negative 4, and 1 all cancel as well. So if we look at just the differences, all of those differences, which again, differences could be distance, if we just were to add them up as is, we'd get 0. That's why we have to square these numbers, because we don't want the difference to end up being 0. We want to get some sort of measure of how far apart everything is from the center. And so we have to square it or absolute value in the mean absolute deviation, as we'll see in a moment. So the standard deviation chooses to square them. So you'll see the squares in that last column there. Then I use the formula, which just says add up all the squares and divide by the total number of numbers. Then take that square root. And we get about 10.23. What this is telling us is that the typical distance of each data value from the mean is 10.23. In context, that means within one standard deviation, a movie should be 123 minutes plus or minus 10.23 minutes. Sorry about my screen moving all around. Because we're talking about whole minutes here, I might adjust this to be 123 plus or minus 10 minutes. If I was within 2 standard deviations, it would be 123 plus 20 minutes. And within 3 standard deviations, we would look at 123 plus or minus 30 minutes. And anything outside of 3 standard deviations is viewed as too far away or potentially an outlier. It's too different than the rest of the data sets. Feel free to figure out what these within 1, 2, and 3 standard deviation numbers actually is to see if we have any outliers. I'll let you know we don't have any outliers, but in case you're interested. Now, I promise you that mean absolute deviation is much easier a calculation than standard deviation. You still have to look at the data value, each individual one, still have to look at the mean, still have to look at those, I call them distances because we're going to make them be absolute value. And again, if we don't do absolute value, we're going to get that 0. We don't want to get 0 for our numerator because then our deviations are all just 0 and that doesn't give us any information. Again, we just add up all those distances, divide by the total number of numbers, and we get 8. That means that every different movie should be about around 8 minutes plus or minus from the 123 minutes we found for the mean for this data set. Lastly is the range, and the range is just take the biggest number and the smallest number, subtract them, we get 17. So for phase 1 of MCU, the range of movie lengths is 17 minutes. Even just with that little bit of information, that the mean is 123 minutes and the range is 17 minutes, we get a better idea of where all of the data lies in between. For your own calculation purposes, I give you the calculations for phase 2 and phase 3. I suggest working on this and then meeting with me via office hours, whether we're in class or you want to set up your own Zoom meeting is totally fine. Or you can email me or ask on a discussion board on Beachboard. I'm happy to help in any way that I can. I hope you're having a great day. I'll talk to you soon.